All right, Algebra 2, Chapter 4, Section 2, adding and subtracting matrices. Okay, in this lesson we're going to learn how to do that. Okay, to add matrices A and B, they have to have the same dimensions. You just add corresponding elements. So here's a here's a tougher way to look at it. But let's just put variables in every case. So what's the size of matrix A and B? Well, it's rows by columns. So each one has a size of 2 by 3. So we can add these. So we're just going to add corresponding elements, okay? So if to add matrix A and B, you would add, let's use our highlighter, element A and element R to get A plus R, okay? In the same corresponding spot. It'd still be the 1, 1 spot. Okay, you'd add element B to element S, and it would just be B plus S, and so on and so forth. C plus T, and it's the same corresponding spot. All right, so element 11, A11 is A, element B11 is R, so the new one would just be A plus R, so on and so forth. So it'd be D and U, D plus U, E and V, E plus V, F and W, F plus W. Okay, now let's take that and let's try to apply it to numbers. Okay, write two 2x4 matrices to represent the mean verbal and math SAT scores. Okay, so we have a diagram over here, and for male and females, how we're going to break it down for verbal. So the first matrix is the verbal. The rows are the male or female, and the columns are years. So we just plug it in. And it says find the combined mean SAT score for each year in the table. So we're just going to add the two matrices together. So the male was 505, the male was 505 in verbal and 525 in math, so a combined score, 505 plus 525. The female was 502 and 490, and so on and so forth. And you're just going to add all the elements in. Okay, we're not going to work through that because you guys can do basic math. All right, so here we go. Now let's just look to make sure we all understand what we're doing here. Find these two matrices, the sum of them. First, let's make sure they both have the same rows and columns. So this one's a 2 by 3. This one's a 2 by 3, so we can add them. So now we're just going to add like terms or like elements. 1 plus 3 is 4. Negative 2 plus 9, 7. 0 plus negative 3, negative 3. 3 plus negative 9, negative 6. Negative 5 plus 6 is 1. And 7 plus 12 is 19. So there you go. All right. This matrix is a 3 by 2, 3 rows, 2 columns. This one's 3 by 2. We're adding them. So again, same concept, same thing we did before. All right, negative 12 plus negative 3 is negative 15. I'm just going to go down. Negative 3 plus 2 is negative 1. Negative 1 plus negative 1 is negative 2. 24 plus 1 is 25. 5 plus negative 4 is 1. And 10 plus 5 is 15. Okay? Using identity and inverse matrices, okay? Let's just go through this if this makes sense. Identity matrix is when it's a matrix just all zeros. So if you added a matrix of 1, 2, 5, negative 7 plus a matrix of 0, 0, 0, 0, you're just going to get your original one. All right, now inverses. Remember, inverses are the opposites. So if I got a matrix of 2, 8, negative 3, 0, and I'm adding it to its inverse, negative 2, negative 8, 3, and 0, it's all going to cancel out and be a 2 by 2 matrix of zeros. Okay? So let's look. What do we notice about this matrix? It's an inverse matrix. So it's just going to be a 2 by 2 matrix with just zeros. Moving on. Okay, here's an identity matrix. So it's just going to rewrite the other one. They're just adding them. So 0 plus anything is whatever we're adding 0 to. Matrix addition. All right, if A, B, and C are n by n matrices, meaning they have the same size, A plus B is an n by n matrix. That's the closure property. A plus B is the same thing as B plus A. That's the commutative property of addition. A plus B plus C is equal to A plus B plus C. That's the associative property of addition. So you should notice the properties of addition hold true. There exists a unique matrix O such that O plus A equals A plus O, which equals A. That's the additive identity matrix. That's the one with 0. For each matrix A, there exists a unique opposite matrix, negative A, where if you add them together, it equals 0. So that's it for the properties of matrix addition. All right. You can define a matrix subtraction by using the additive inverse. So if you have two matrices, A and B, that have the same dimensions, then the matrix A minus matrix B is the same thing as matrix A plus the additive inverse of B. So let's see how we do that. All right. So I have two matrices. I have matrix A, and it is 3, -1, 2, 4, 4, 0, minus matrix B, 1, -2, 4, 2, 3, 4. Okay, the way I think of it, I'll show you the way I do it first, and I'll show you the way the book shows you can do it. And whichever way works for you is the right way. Okay, so I go 3 minus 1 equals 2. 2 minus 4 is -2. 4 minus 3 is 1. -1 minus -2 is +1. 4 minus 2 is 2. 0 minus 4 is -4. I just actually go through and subtract every time. That's the way I get it done. Okay? The book says now you can show and do the additive inverse. So let's erase it. So change this negative sign to a plus, but then change all the signs inside the box, and now you add them together. So 3 plus -1 is 2. 2 plus -4 is -2. 4 plus -3 is 1. -1 plus 2 is 1. 4 plus -2 is 2, and 0 plus -4 is -4. So you notice you get the exact same answers. So it's really either way that's easiest for you not to make mistakes. Okay, so let's just do one more really quick, or a couple more. So 6 plus -4 is 2. Remember, in matrices, to add and subtract, they have to be the same dimensions, and then you sum corresponding elements. So again, 6 plus -4 is 2. -9 plus 3 is -6. 7 plus 0 is 7. -2 plus 6 is 4. 1 plus 5 is 6. And 8 plus 10 is 18. Okay, last example. They're both 2 by 2 matrices, and we're going to subtract them. I'm just going to do it my way. -3 minus -3, that's 0. 5 minus 1 is 4. -1 minus 2 is -3. 10 minus -4 is 14. So that's kind of how we do it. So that's the basics, nuts and bolts of adding and subtracting matrices.